That's a pretty cool effect. Greetings, the Astro 30 here yet again, and welcome to part 2 of this classic D, Class D amplifier build, where I actually build the thing into a enclosure. Now, in today's video, we're going to look at what's going to be needed here, which is, well, the basic preamp. Well, not so much the preamp, but the tone control network, bass, mid-range, and treble. And here's the basic circuit here. If we look, we can see that this first input stage here, this is just giving us a low impedance path here for this network, but with this resistor here 10k and this resistor here also 10k, we're looking at a gain of 2. Now, it's not a gain of 1 because gain is calculated 1 plus resistive feedback divided by resistive gain. So 10 by 10 is 1, plus 1 is 2. So for an input level of, say, 1 volt peak to peak, we expect to see 2 volt peak to peak out here. Now you may be saying, that's not a lot of gain, Astro. No, it's not. But you'll also notice there's no volume control attached anywhere here. That's because it's over here in our linear volume control circuit. Now, as previously stated with this circuit, this is operating actually at a gain of 10. So if you combine the two circuits together, you'll end up with an overall gain, assuming the volume controls all the way to maximum, an overall gain of 20, which is considerably powerful enough to drive those Class D amplifiers. I may have to dick around with the value of the gain here just to maybe give it a little bit more headroom. I don't know yet. But I expect for normal listening levels the volume control to live somewhere around the 8 o'clock, 8:30 position on the dial. Now you'll notice that the rest of the paper here is covered because there's another part to the schematic which is not covered in this video, so to keep things simple, I've covered that part up. But with this circuit, all it is just a standard backsandle tone control network active one, and backsandle is the correct term for it, not band axle, because the concept of the, well, he actually came up with the active volume control. His name was Peter J. Baxandall, and he was an English electronics engineer. So Baxandall is correct. Anyhow, moving on. So this is my overlay diagram, and I do have another one back here. Now, I printed this out mainly because I wanted to, after routing, because I route things manually rather than using auto router. I'm just, you know, crazy like that. I wanted to just verify and check that everything was connected correctly, so I've printed it almost twice the size of what it's actually going to be. And go through and, you know, check that everything is wired in the correct direction. Well, here's the first one that I did, and I noticed when I was going through checking my routing that this resistor here wasn't actually connected to where it was supposed to be. This end was just left floating. That should have been connected to pin 2 of the IC. Because that's part of its feedback network, and it wasn't. So that means I had to move this route here, which is why there's a line now here to tell me when going through the program to change it, and then this route has to go up to there, which then ended up looking like that. So now this route goes around there, and this one joins to pin 2 where it's supposed to. But it's, as we can see, it's not overly complicated. Most of the active electronics is over here in the right hand corner, and all the passive stuff's over here. It does make the board a little bit bigger than necessary, like as in width, but it is what it is. And this is basically my printout of the circuit board looking from the component side down through to the copper side. I printed it out just so I could see what it looked like in physical size. This is it at its actual size, so I just wanted to see that A, components fitted correctly, and that how big things were going to be. I can't remember offhand what size this is, but the board itself measures 163 by 43.5, we'll say. So it's not overly big, but it is big for what it is. It could have been made smaller, and it would have been even made smaller if it was, you know, double-sided, but it's not. And finally, no, I didn't reverse the picture. What we're looking at here is a printout of the silkscreen layer of the PCB from the CAD program, and it's printed in mirror image. Now, there's a reason for that. This is going to be transferred onto the component side surface of the PCB after it's etched using acetone. So the board sits up against this with its component side facing down. You stick the board with tape to the paper, turn it over, you rub some nail polish remover or acetone onto the other side of this paper, let it sit and dry, take it off, and the toner is then transferred to the fiberglass. And it's a poor man's way of doing a silkscreen overlay, although it's not actually a silkscreen overlay, it's just toner transfer. This method will not work for transferring toner to a circuit board on the copper side to assist in etching, but it will give you a visual reference to where all components go by just looking at the PCB without having to look at a separate printout. So that's what I intend to do, and there's a bird stuffing around outside. Bugger off. Now, I'm not going to cover that in this video, doing that. It's very simple. There's plenty of videos on YouTube actually of how to do it, so I'm just going to do it that way. Probably would have been better if it was in the center of the page, but it's not. Anyhow, now I'm not going to be breadboarding this circuit because I've already built it once. I know it works. What I will be doing is making the PCB, obviously, and then running some tests on it. So yeah, let's get on with that. Okay, the story so far is that one didn't quite work out too well. I don't know what happened here. I think it had something to do with the toner on the overhead transparency wasn't on there properly. It's that's not going to be all that great to etch, so I'm not even going to bother. So I redid it, and this one turned out a little bit better. It took less time to develop. The only thing is, it's a brown circuit board. So I'm ready to etch my board now. Hopefully that etches just fine. Yeah, so that's what's going on at the moment. So the cameras, the PCB's all drilled, cut to size, and has a layer of protectant on it. Now, I did try to do the overlay on the other side. It didn't work out too successfully. I've never done it before, so yeah, I've got to refine that technique. I know the method works, it's just that I didn't do it right. So for this instance, I'm not going to worry about it. Yeah, it's just going to be a blank component side. Now, I was wrong. It's actually a lime green colour PCB, which is actually quite cute. Anyhow, I'm going to let that dry, maybe have a Kit Kat, maybe a smoke, a Coke, maybe smoke some opiate, I don't know. And then I'll come back and assemble it. It's ready to assemble. I've got all the parts laid out that I need. Unfortunately, I need a couple of 2N2s, or 0.0022 microfarad MKT or polyester capacitors, even metallized polyester. Unfortunately, I don't have any, so I've got everything else but. So I'm going to have to go down to the electronics store and buy some. However, I've got enough to be getting on with now, so I'm just going to mount this in my tool somehow so that I can assemble it. And yeah, that's going to be awkward as hell. I'll just have to make the best of what I can here, and I'll go out later and that just clears it. It doesn't clear it that way, so I've got to be careful. So I'm going to start with the link wires. Might help to turn the soldering iron on. So I'm going to start with the link wires, and yeah, we're going to do it in time lapse as usual. And I'll assemble everything, including the connectors and pots and stuff. Then I'll piss off out and buy some 2N2s, and yeah, go from there. Okay, and there's a assembled tone amp board now. It's going to stick all the tone controls in the middle. Now all I need to do is insert the two ICs. Now I forgot to mention they're any 5532s, the standard op amps I use, so I'll pop them in. Now this time I've used IC sockets simply because, well, if there's a problem with one of these ICs, it's easy to change. I still have yet to purchase a IC inserter tool. Yeah, whatever. Okay, so the two op amps are now in. Now it's time to hook it up to some juice and test it out and see if this was all worth the effort. It took me around about, I think, an hour to assemble and about 2 hours to manufacture the PCB in the first place. Again, this circuit board does not have standoffs to mount to a chassis. It's mounted via the control potentiometers to the front panel, and because they're dual gang, they should maintain rigidity of the circuit board as long as you don't like push down on the corners or anything. Now I'm going to borrow the connectors from the volume control board, save making up some more just to test it. I will need to hook it up to a power amp, or the power amp that I've got. I still haven't assembled that other Class D module yet. I'll get around to it, but I'll borrow them and figure out something as I go. I did, however, go out beforehand and buy the two N2 capacitors before I started assembly, and I also went and bought 10 of these IC sockets because, well, I thought I had some and I don't. So without further ado, I need to hook up my power supply, but first I need to mark with the texter on this connector here a blue mark there, just so I know that that's the negative connection. Positive's at the top. Alright, so let's go. Alrighty then, I've got everything set up. Got the USB based oscilloscope for the measurement because, well, it's bigger. Got the DDS set to my standard 1 kHz 1 volt. So everything's hooked up. Power supply is preset to 15.2 volt plus minus, thereabouts. So with any luck, as soon as I turn the power on, we should see on the scope output there a output voltage of 2 volt peak to peak, with any luck. So I'll turn the load on, and bingo! We have about 2.1 volt peak to peak coming out. That's brilliant. So if I play with the treble control, you can see that it increases and it decreases. Now if I fiddle with the mid, it increases, doesn't appear to clip. What are we pushing? We're pushing 7.1 volt peak to peak, and when we cut we're pushing 690 millivolt. As for the bass control, there is a slight increase because 1 kilohertz is not a bass frequency, so that's probably, you know, about 0.1 of a volt difference, and the same with cut. So if I set my DDS now for a frequency of, say, 60 hertz, now I'm going to have to adjust the time base obviously because it's wrong. If I now change that to 10 milliseconds, now if I play with the bass control, you can see a significant increase. Now we're getting 10.2 volt out, but I don't know if that's clipping. And in cut we're getting 500 millivolts. So if I now just change my volts per division here to, say, 5 volts, just so I can, or we can see the waveform a bit better. Yeah, that's severely clipping, so I'll back that off.
and give the scope time to catch up. So about there, which is almost a 3 o'clock position on the pot, sorry, yeah, 3 o'clock. We're getting roughly 8.4 volt peak to peak. But that's at 60 Hertz. So I'm going to change that to 160 Hertz. And we can see there was a significant drop in output voltage there. So we can see that this bass control is operating around the 100 Hertz range. So what I might do is change that to 100 Hertz. And at the 3 o'clock position, we're not clipping. And yeah, that's maximum. So get 9 volt peak to peak. So I am going to go out on a limb here and say that the center frequency, or the center frequency of the bass control is going to be in the order of around 80 Hertz. So well, that's average enough. So I'll change that to 80 Hertz just for the hell of it. Not seeing anything really significant there. Oh, now it's starting to clip, yeah. So I'd say around about 80-90 Hertz is the center frequency of that, which is okay. I mean, you're not going to sit there with the bass control full up. Well, you might, but I wouldn't. But yeah, and the mid-range control is doing absolutely jack shit to that frequency range. So I reckon the center frequency of the mid-range control is 500 Hertz. So we're getting a very significant increase. And it's actually probably more closer to 1 kilohertz where it was. As for the treble control, probably 16,000 Hertz. Or 16 kilohertz. So it's 16,000 Hertz now, we can't see anything. So I'll change that back to 1 millisecond. It's a very poor waveform, but yeah. So that's the increase of the treble decrease. Yeah, so the preamp is working on that channel at least. So I'm going to change that back to 1 kilohertz. And now I'm going to swap channels, because that was the left channel. So I just want to make sure that the right channel is also functioning. I mean, I could have hooked up, you know, both inputs of the scope there to get the result, both things on the screen at the same time. But yes, and it's roughly the same. Nothing unusual there. Bass is not doing anything to 1 kilohertz. Treble's not doing much to 1 kilohertz. So it works. I'll change the frequency back to the 60 Hertz range and play with the bass pot. Yeah, that's working. And change the frequency to the 16,000 Hertz range. Yep. Okay, so I know that the thing is working as a preamplifier and the tone controls are doing what they're supposed to be doing. So now I'd have to hook it up to the power amplifier via the volume control that I've got, volume control board, which will give me an extra gain of 10. So, and do a sound test, which is going to be awfully awkward considering I don't have another connector made to make that possible. However, I'm sure I can figure out something. Right, wow, okay, leads every frickin' where. Just going to turn my power supply on and make sure there's no unusual current draw. No, there's not. Now the only thing left to do is to plug the power amplifier in and hopefully nothing is wrong. I've checked that all connections are correct. So all I've got to do is just plug this power lead in and hope for the best. Okay, nothing really weird there. And we do have an output. Okay, now to hook it up to a music source. Okay, let's play some music and see what it sounds like. So here we go. Shit. There's quite a considerable amount of gain there. Bass, no bass, mid, no mid, treble, no treble. I'll give it a bit more bass. There we go. Excellent. All I've got to say is that sounds absolutely wonderful, and there is a shitload of gain there, probably more than necessary. That volume control pot is sitting at the 9 o'clock position, which is just a little bit above my normal listening level. So what I'm going to do is I'm going to go back a track and play with the volume and see what it sounds like. Maybe not that track. Or that. Try that one. Now I reckon the volume control will live about there, which is probably about 845. But it is pushing quite a bit of gain when you rotate. Right, well I don't want to blow those speakers. I know that amplifier is capable of 150 watts. And these drivers are only capable of 25. Yes, anyway, I'm quite happy with the performance. Now, this volume control board I'm going to be remaking, mainly because, well, I want to use IC sockets for a start, but because of the, not so much because that edge where the connector is for the power is cut at a funny angle, but mainly because the edge along the front there is a little bit too far out this way for it to mount to a panel correctly without having to washer it up. I don't want to do that. So I've got the ability, I think I've already done it, is to modify that and move the board edge in a bit, redo it, and yeah, I might go back to a 50k linear pot here instead of the 100 to see if it's less reactive. However, so what happens here is the input signal comes into the main preamplifier here with unassisted, there's no volume control. The volume control board is connected via the output connector, which is over here, before the power amp. So that board sits in between the preamp and the power amps. But yeah, I'm extremely pleased with how this turned out, and that it's in its current gain configuration is more than enough to drive the power amplifier properly. Yeah, I don't have to do any modification to it, and this is the reason why I didn't breadboard this circuit up first like I normally do, is because, well, I already did that back in 2011, and well, actually probably earlier than that, 2009, so I know that the circuit works. I just redid the board layout a couple of days ago, which is the reason why I haven't uploaded many videos lately, is because I was busy working on doing this preamp. But anyway, that's working, I'm happy. I might play another track to end this video, and as always, this is the Astro 30 saying thank you for watching, and if you enjoyed this video, please remember to rate, comment and subscribe below. And you can always follow me on Facebook and Twitter, the links are in the description as usual. Anyway, this is the Astro 30 saying happy preamplifier. Cheers. That would probably sound better with a subwoofer too. See you later.